Hello, lab partner. We are ready for our fourth lab, and that is going to be on moles of iron and copper. So you want to go and grab this bad Larry here from Essential Documents, moles of iron and copper. Now, of course, when you go to Essential Documents, it's going to say lab 3. That's because I switched those to the order for the class. But that's all right. Doesn't make any difference. We're going to move on and do the third lab fourth. Here we go. So at this point, what I have is some purified, distilled dihydrogen monoxide. That's right. This is the concentrated dihydrogen monoxide. So we've got some of that. We're going to make our solution out of that. That's water, by the way, water. Okay. And then we have some cupric chloride or copper 2 chloride. And the copper 2 chloride is actually a blue, and health hazard, you could see it on there, blue 3. This is not a fun compound. I would warn you repeatedly, wash your hands if we were together and you were doing this lab. It's a poison, so don't you worry. I'm taking one for the team. You guys just sit back, relax. Grab some popcorn, grab some ice cold root beer, and watch me handle the poisonous compound. We're going to actually make a solution out of that, and we're going to put that solution into this beaker here. And you say, "Ooh, that's a nasty looking beaker," because this reaction actually causes a nasty reaction, which is why I keep the same beakers when I do this reaction. I like this lab. This lab if it goes well, it comes out with some really good data. It's kind of neat looking visually. So yeah, so I just keep doing it because I like it. But it does kind of crush our beakers. And so this beaker here, I just keep them. That, by the way, is a clean beaker. It doesn't get any cleaner than that. I rubbed it and cleaned it several times with the iron staining on there. Just you can't get rid of it. All right, so we're going to have to mask that. We have 2 nails. All right, got ourselves 2 nails. And let's start gathering some data. So you can see on the data table, now that you've gotten that, while I've been bantering, you've gotten your essential document out and looked up the lab, you printed it off, or not. I mean, second page, we have a data table. And the data table, first thing, is mass of the empty dry beaker. So let's go ahead and we will get that mass together. La, 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 la. La, la, la. La, la, la. There's no air currents in here, but I will put that down anyways. It's pretty dead in here. It's pretty hot in here. It's like dead air. 102.572. 102.572. So lab partner, write that down. Okay, you take the data down, right? I'm getting it. And then we need the mass of the beaker and the copper chloride. Now that I'm going to have to add approximately 4 grams of the copper chloride. Approximately. It says 4 grams in the instructions. If you go back to the first page here, it does say that on there. There it is. Oh. It's not easy. You think this is easy? This is okay. 4 grams, but I'm going to add approximately 4 grams. It doesn't make any difference if it's 4.1 or 3.98 or 3.75. It doesn't matter. As long as we write down exactly what we use, we'll be fine. It does not have to be exactly 4 grams. So I'm going to add approximately 4 grams. And I have right here 102.5. So in my brain, I'm doing the math saying 106.5 is what I'm looking for. So you just hang on there, lab partner. Putting you down. Sorry, I know. Let me up. So 106.5-ish is what I'm looking for from this nasty chemical. Nasty chemical. I know, it's boring. You're wondering what the heck's going on. Well, take a drink of your root beer and eat some popcorn. Okay, all right, not bad right there. We'll leave it. That's good. Close enough for government work. All right, lab partner, you're back on. All right, you back? You with me? Okay. I said 106.5. I had a little bit more than 4. 106.741. 106.741, 106.741, 106.741, 106.741. So that is the mass of the beaker and the copper chloride. Now, if you want to get the mass of the copper chloride, you're just going to take those two and subtract. That'll give you how much copper chloride, how much of this chemical here that I added. So you go ahead and do that because I have faith in you, lab partner. You can do that. I do need the mass of these 2 nails. That's important. We have to get the mass of these 2 nails. So we're going to take this off. We're just going to take these 2 nails and we'll just re-zero this. Okay, zeroed. Add 2 nails. And we get 5.309. 5.3, well, it's making up its mind. All right, we'll go 10, 5.310. So mass of the 2 iron nails, 5.310. All right, lab partner, for now, that's what we needed to do. This is all before the reaction, and what I'm going to do is I'm going to add, there it is, 15 milliliters of my distilled hydrogen monoxide, and we're going to put it into that beaker. And when I do that, I'm going to come back to you. I want you to make an observation about what you see, and this is at the start of the reaction, and then we're going to have to let this cook for, typically what I would do if we were together, we'd set it down for the week and come back the next week and pick the lab up and just let it cook for a week. But you really need about an hour. So at the second page, where you can see I put a blue line underneath step 6, that's because at that point we're going to let it cook. So I'm going to let it cook for about a couple hours probably. In the meantime, I'm going to make some other sweet videos while it's cooking. But hang on, we'll be back in just a second here.